All right, we're going to go over linear equalities. So these will be inequalities in one variable. So first of all, let's go over the symbols. This symbol, this first one, means is less than. The second one with the little line underneath it means is less than or equal to. The third symbol is greater than. And the fourth symbol, again with the line underneath, means is greater than or equal to. So if we put some numbers in here, for instance, we could say like -4 is less than 2, for instance. Or we could say 3 is less than or equal to 4, right? Because what it's saying is either 3 is less than that number or it actually equals 4. So we could also put 3 is less than or equal to 3. But if it doesn't have the line in it, you cannot have the same number on both sides, right? Another example might be 5 is greater than -6, or -2 is greater than or equal to -5, etc. Now, we're going to be dealing mainly with some variables, so we might have x is less than 2, etc. But here are some true inequality statements. All right, so here are some statements, and let's go over how you would graph these particular statements. All right, x equals 2. That means that the only number you could put on the graph for x is right at 2. So here would be a dot right on x equals 2. All right, let's do x is less than 2. Well, this means it can't equal 2, but it's all the numbers smaller than 2. So there's a lot of numbers smaller than 2. For instance, 0 is smaller than 2, -1 is smaller than 2, 1/2 is smaller than 2, etc. So all these numbers to the left of 2. So what we do in that case is we put a circle around the 2 to show that's not a solution, and then we're going to draw an arrow to the left. So let's do a circle on 2. Okay. And then we're going to draw an arrow to the left to show we want to pick up all the numbers smaller than 2. Now the next one says x is less than or equal to 2. So we need to put these two together. It can equal 2, so we have a dot on 2, and we also can have all the numbers less than 2, smaller than 2. So you would have a dot on 2 and pick up all the numbers to the left. So you make sure there's a visible dot here on 2. All right, let's go to the next one, which is a greater than problem. X is greater than -1. So again, this means that it is not equal to -1, right? But it's all the numbers bigger than -1. Again, like 0 is bigger than -1, 1's bigger than -1, 1/2 is bigger than -1. So -1/2 is bigger, but not -1 itself. So we need to put a circle on that to say do not include that number -1, but we want all the numbers to the right, all the numbers bigger than -1. And the last one says x is greater than or equal to -1. So this solution also includes the number -1. So we could put a dot right on -1 and also include all the numbers to the right of -1. So you make a visible dot here. All right. So what you might notice is when you have the variable on the left of the inequality symbol, okay, notice that it says x less than 2. If the x is on the left, if you've solved for x and it's either less than or equal, greater than or equal, etc. So if the inequality symbol is pointing, see the small point is pointing to the left, the arrow will also be pointing to the left. So notice that the arrow is pointing to the left here. So both of these, the arrow is pointing to the left. Here, the third and fourth one, the inequality symbol, the greater than symbol, is pointing to the right, and the arrow is also pointing to the right. Now, here are two problems where we do not have the variable on the left-hand side. Instead, it's on the right side. It's much easier to read when x is on the left-hand side. So the way you would read this, since we normally read left to right, it says 2 is less than x, But you can turn that around and pretend you're reading from the other side. That's the same thing as saying x is greater than 2. So imagine you start over here and you read backwards. It says x is bigger than 2. Same thing here. If you have negative 3 is less than or x, you need to read it or turn it around to say that x is less than or equal to negative 3. So that's like saying 2 is smaller than a big number, then a big number is bigger than 2. Here it's saying negative 3 is bigger than some small number, so some small number is less than or equal to negative 3. So it's much easier if you turn it around so that variable is on the left-hand side like that. So you want to be able to practice that. Then it's easier to graph. So now I could say x greater than 2. It does not include 2, so I have to put the circle on the 2 and I have to go to the right. So notice if you left it as 2 is less than x, when the x is on the right-hand side, the arrow points a different direction than the inequality symbol. Let's do the second one. It says if negative 3 is bigger than x, you could say greater than or equal. So it could be equal, but it's saying negative 3 is bigger than all the values. That means all the values must be to the left. See, it's kind of strange to write it that way. But if you had looked at the second way I've written it, x is less than or equal to negative 3, it's easier to see which way you're going to point. All right, so this is a little hard to read because I'm going to the left and I didn't draw that big of a number line. You might have a problem like this where it says negative 2 is less than or equal to x is less than 1. What this means is negative 2 is less than or equal to x, and at the same time x is less than 1. So first of all, you want to make sure in order to do this that if you have a less than or equal to symbols, the smallest number has to be on the left and a larger number is going to have to be on the right for this to even be possible. And secondly, you've got to make sure they're both less than or equal symbols. It can't have one of them be greater than and one of them be less than. That won't work. So what we do is this really means that x is sandwiched in between those two numbers. So if here's 0, here's negative 3, let's say, and we've got 3 over here. What it's saying is x is in between negative 2 and 1, and in fact, negative 2 is actually one of the numbers, so we could put a a dot on negative 2, and we can go all the way up to 1, but it doesn't touch 1 because it's not equal at 1, so we would have to do the circle at 1. So the dot on negative 2 because of the equal sign here, and the circle on 1, and that's like saying x could be any of these numbers. For instance, if x was negative 1, this would be a true statement because negative 2 is less than or equal to negative 1, which is less than or equal to 1. It's saying negative 1 is in between negative 2 and 1. All right, so you want to practice just graphing once you have something already in the form x is greater or less than something, and also if x is sandwiched in between two numbers. So this is just a little introduction, and then you want to go on to part 2.